All right, so this is the key for your take-home Quizam 3. And I'm just going to work it like this, and I'll post it. And then I will grade you and give you your feedback. Okay, so the correct answer for 1 is B. So the first most acidic compound is the one with the fluorine, which is the most electronegative, and it is literally from this oxygen here. So if you were to draw its conjugate base, you see that it's 3 bonds away. Okay, and then second would be this one here with the chlorine. Chlorine is less electronegative than fluorine. And then the third is this one here. The fluorine is 4 bonds away, so it's further away. And number 1 has no electron withdrawing groups. So that would be the least. So the answer there is B. All right, let's look at 2. Arrange the compounds in decreasing basicity. So your most basic is going to be 3. So this is your most basic. It's an aliphatic amine. And then, so your answer is going to be D. So 3 is your most. Number 1 is second because it's ammonia. It doesn't have no electron donating groups. And then this would be your third because that's an aromatic. So we've talked about aliphatics are more basic than aromatic. And then the last one is an amide. And we've said that amides are not acidic. 3, your answer is D. So you're going from a primary amine to an alkene. This would be exhaustive alkylation followed by elimination. This is called the Hoffman elimination. And your intermediate here would be these CH3s here would all bind to the nitrogen, and then the OH generated here would take one of these beta hydrogens and do an E2 elimination to give you 1, 2, 3, 1, 2, 3, your product. All right, so number 4, the answer is B. So the first thing that happens is benzylic oxidation. And you see that this group here cannot be oxidized because that carbon has no hydrogens. But this group here can be undergo benzylic oxidation. And so from step number 1, your product would be this carboxylic acid. And then step number 2 is Fischer esterification. So that converts a carboxylic acid into the methyl ester. And that's your answer, B. Okay, problem number 5, the answer is A. So let's look at this sequence here. This is a amide. It is a meta-director, and this is an NO2. So you're going to nitrate the ring. So the first step you're going to get is nitration. And then the next step is going to reduce the nitro, the Clemenson. So the next step would reduce that nitro to the amine, NH2, the aniline. And then the sodium nitrite, HCl, that is going to make your diazonium salt. So that turns that into the diazonium salt. And then from there, this can substitute this for the fluoride to give you that product. So A is the answer. Problem with B is this is not a pair director. The problem with C, we've lost our amide. And this would be bromination. So none of those work. All right. So now we are on problem number 6. Devise a reaction scheme for the following reaction. Okay, so what we've done is we're going from a tosylate and we've added a carbon. Okay, and we've made a secondary amine. So I'm thinking the nitrile, and I'm thinking maybe reductive amination. Okay, so let's do this reaction scheme. The tosylate, if you react this with sodium cyanide, and I do see a little error in this because this would give you inversion of stereochemistry. So there's the reaction. So B is your answer. The next thing you'd want to do is dibal. So dibal is going to reduce the nitrile. To the aldehyde. And then this is for primary. We're not oxidizing. We're not doing the diazonium salt. And then you would do reductive amination, which would be throwing a little bit of acid. And then your second would be a reducing reagent such as sodium cyanoborohydride. And that would give you your product. So B. Okay, number 7. The best reagents to go from a primary alcohol to a primary amine. And you need all that apply. So what you're going to do, the first thing you're going to do is tosylation, so A. And we did not add carbon, so we don't need B. This is a primary amine, so you should be thinking Gabriel. So the first thing that's going to happen is you're going to make O-tosyl, which is a good leaving group. And then when you add the phthalimide, you're going to make this compound here where you've installed the nitrogen here on the phthalimide. And then you're going to release it with hydrazine to give you your primary amine, which would be this group here. So you need A, C, and D. If you choose B, that's a -2 points. And if you miss one of them, it is a -1 point. Okay, 8. The answer is C. So if you use dibal with amide, you would not get the aldehyde. That would only work if you had a nitrile or an ester. Lithium aluminum hydride would work. You cannot go from an amide to an ester, and you can't go from an amide to an acid chloride. So the answer is C. Number 9, the answer is D. So you're going from a carboxylic acid to a methyl ester. And this is Fischer esterification. The 3 things you need are the carboxylic acid, the alcohol, so this is your alcohol that gets installed, and the acid. So the answer is D. Number 10, The answer is C. So if you do this reaction here, the first thing you do is you nitrate this ring, and this is going to be an ortho pair director. So that would put the nitro group there. The second thing you do is you make the diazonium salt. So this would be and then the copper cyanide, the Sandmeyer reaction, will replace that with cyanide, the nitrile group. So that would be C. Okay, the next problems, so that would be 30 points of your Quizam. The next problems on this page are worth 10 points, 5 points apiece. The first thing is, this is the Hoffman. So we're doing a Hoffman elimination, and it requires you to show the mechanism. So the first thing you want to do is you want to show your exhaustive alkylation intermediate. Okay, so this is worth 1 point. The second point is we'll put 1 point. This is your ammonium salt. So if you've drawn that, you get that point. 1 point is your electron flow arrows. So this is your alpha. This is the beta hydrogen. So I need to see your electron flow arrows coming and taking that beta hydrogen and pushing the trimethylammonium. So you're going to lose the NH, you're going to lose NCH3, and you're going to get this product. The product is worth 2 points. And I'm sorry, the ammonium salt is worth 2 points. So now for your bonus here, this is all or nothing. Okay, so you got to have, we're going to label the Newman projection. I'm just going to go with this here being that alpha carbon. So I'm going to put my nitrogen on top, and then my back, this would have to be the beta, would have to be the back carbon here, and I'd have to show all my hydrogens here. Okay, and then what's coming off of here would be C, H3, H, CH2, CH3, the rest of the ring, and a hydrogen. If you did it the other way around, it would look like all your hydrogens there, and then on the back you would have your ammonium salt there, and then the ring would be coming off here. You also have to show electron flow, so you'd have to show your O minus either coming in, taking this hydrogen here, or if your O minus came in on this drawing, you would show it coming up the top and your 3 electron flow arrows like such. And the reason, the explanation, a single sentence. I'm looking for that this is an E2 stereospecific reaction mechanism, and the beta hydrogen that gets abstracted must be 180 degrees anti-periplanar from the leaving group, which is your trimethylammonium salt. All right, for the next one, number 12, you're to write your major organic product, use electron flow arrows, correct formal charges for the mechanism. Okay, so the first thing, you want to show your lone pairs, and you need to draw your tetrahedral intermediate. All right, so this is your tetrahedral intermediate, and you have to have your formal charges correct. Okay, this is worth 1 point. Now, this is going to be your leaving group, so you need to show your electron flow arrows where the chlorine leaves. Okay, so your electron flow arrows are worth 1 point. Okay, so 1 point is for the tetrahedral intermediate. The other point is these electron flow arrows showing the chlorine leaving. And then when that happens, you will get this compound here. And you could just show your neutral amine, which is worth 1 point. You also need to show your pyridine, which absorbed that hydrogen, which is worth a point. And then the electron flow arrows. So actually, yeah, your product will be worth 2 points. 2 points for your product. 1 point for your tetrahedral intermediate, 1 point for your electron flow arrows, and 1 point for the pyridinium HCl proton sponge. All right, so your last problem was fill in the boxes below and for the reagents, the missing reagents. Okay, the first thing I'm going to do is the 12 o'clock. So we're going straight up here, and this is the Jones oxidation. So you can write Jones, or you can write sodium and the chromium, or you could write H2Cr2O7. If you do the sodium, you should put sulfuric acid in there. Okay, and then the next reaction, each one are worth 1 point each. Okay, so these are 1 point each. Okay, so our next problem would be, let's go to the 3 o'clock, and we have a secondary amine. So we want to probably do reductive amination. We need a ketone or aldehyde. We have a primary alcohol, so PCC is going to get you your aldehyde. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So make sure you get the right number of carbons. 1, 2, 3, 4, 5. Okay, so once you have your aldehyde, you can react this portion of the amine. So you want benzylamine. You'll need a little bit of acid because it's to form an amine. And then you want to reduce this with sodium cyanoborohydride. All right. Now let's go to the 9 o'clock reaction over here. We're using the phthalipid with hydrazine. So we're making a primary amine from an alcohol. what you want to do here is convert the primary alcohol into the alkyl bromide. So PBr3 works there. And then the intermediate, which I'll draw here, that you did not have to draw, would be 1, 2, 3, 4, 1, 2, 3, 4, 5. And then hydrazine releases this amine. 1, 2, 3, 4, 5. Okay, what we have here is the Hoffman elimination. So that is going to make an alkene. And then to go from an alkene to the aldehyde, you can't go through the alcohol here because you only have 4 carbons. And here we have 5 carbons. 1, 2, 3, 4, 5. So we're cleaving that. So we got to do ozonolysis and DMS. I know some people put potassium permanganate, but that would give you the carboxylic acid. So you need ozonolysis here. And then this is going to make the amine. So we're going to lose water. So we're going to lose that oxygen and that hydrogen. We're going to lose water. And basically we're going to make a carbon nitrogen double bond. 1, 2, 3, 4. 1, 2, 3, 4. And then here we have 1, 2, 3, 4. 1, 2. All right. So 1, 2. 1, 2, 3, 4. 1, 2, 3, 4 plus 4 is 8 carbons. And there's your amine. All right. So hopefully I took all bonuses out because of the circumstances of giving the Quizam. Our high score was a 49 out of 50. Good job. And everybody did really well. Our averages were about 76% average. So I think the next exam will be on sapling. So we'll start with a quiz next week on sapling on Wednesday, and you'll have that day to answer that quiz. So we'll get used to doing that. Okay, I'll see you later. Have a good weekend.